Okay, Assalamualaikum and good day. Right, so I'm going to do some discussion on design question, but I'm not going to go into details like how we're going to do the design question, but I'm going to show you guys what are the important step involved in a design question, right? So basically, the open book exam will be consist of a design question that covers most of the knowledge that you have learned in POCA subject. So but I'm going to show to you guys later, so what are the important things that you have to go and look into and try to understand how it's being done. Okay. Right. So, if there's a design question, normally you guys going to be asked to design a processor because the main objective in this principle of computer architecture subject is that you guys are able to understand how the processor function and how to design a complete processor system, but fundamentally lah, but not in depth, right? So when you're being asked a processor design, so there are five important things to look into, which are covered in most of the chapters that you guys already gone through, right? So the first one is instruction, which is the most important part in for the processor design, because without an instruction, so the processor doesn't mean anything. The instruction is the one that determine what the processor can do and cannot do. Even if you see in the architecture, right? So the instruction architecture, they have race reduced instruction and also complex instructions. So that are the one that determine how they design the processor. So if race, they have different architecture, and also for the CISC, they also have the different architecture. Right, then memory, cache, bus, and also multi-core design. Okay, let's go into instructions. Okay, so for an example, so when you being asked to design a processor, right? So the first thing is that you have to determine the number of instructions involved. So if the question didn't tell you what are the number of instructions involved, then you can assume. But if they already tell you, then you have to use the number that the question already tell you, right? So for in this case, let's say the question didn't mention, right? So we can just assume. So we can say, for example, for our computer, so we have 32 instructions. So we are using 32 instructions, right? So that means we need a space to store 32 instructions in the memory, right? So normally in the computer design, right? So we're not going to have a separate memory like instruction and also data memory. Normally we have only one memory, right? RAM, and then we're going to divide it. So there's a portion that we have the instruction, and then the other portion we have the data, right? So in this case we have 32, so we need to have a location to store 32 set of instructions inside the memory, right? So the rest we can use it for data, right? So that's for instructions. Okay, then we go into memory, right? Okay, so given right, the question already give you, for example, they say that okay, our system need to have 64 megabyte of main memory. All right, so and then the question already mentioned, and we are designing a 32-bit data computer, right? So that means we're going to store the data inside memory location. So in one memory location, so it's gonna be we're gonna have 32 bits of data, right? So we can store 32 bit of data in one location. So that means we're gonna have, let's say, F, right? So a hexa, we're gonna have 8 hexa, 1 2 3 4 5 6 7 and 8 hexa, right, in one location. So we can store 32 bits. Okay, now we have to calculate, so what are the total memory location, right, that we have. So we know that 64 mega equal to 64 million, right? And then here is byte, right? It's not bit, so it's byte. And then we know one byte contain 8 bits. So we just time 64 million times 8, and then we divide it by 32 because each location can store 32 bit of data. Then what you get is that you're going to have 16 million memory location. Right, so from the 16 million memory location, then we have to determine, so what are the address, right? So what are the address for main memory that we need to have, right? So we calculate, right? So we just use the multiple of 2. Like you can try, right? So you can try, then if you do 2 to the power of 23, then you're going to get 8 million. And then if you do 2 to the power of 24, then you can cover up until 16 million numbers. Okay, wait. So I think something wrong. Yeah, I'm missing certain number. Wait. Oops. So open the calculator. Where's my calculator? Okay, alright. So let's say we do. Oops. What happened? Right? Okay, it's fine. Okay, 2 to the power of 24. Right, so what we get is 16 million, 16,777, right? So missing 1 7 there. Okay, all right. So, right. So this is the most closest one that we can go. So, we have to say that okay, our address for main our address for memory in our system will be 24 bits. Okay, so we have to share the instruction and data, right, for the memory. Okay, so the instruction will take location 0 up until 31. So we have 32 instruction, and then location 33 onwards then will be used as data memory, right? Okay, then for cache, right? So for cache, okay, cache is a must in a processor design, right? So whenever cache involved, then we as a designer, so we need to determine and design the connection. All right, so okay, in this design question, normally it's going to be an open ended question, so it's really depend on us, right? So what are the connection that we can use? So it's up to you. You can choose to use whatever that you think that's easy for you. If the question if the question didn't specify, but if the questions indeed specify, so you need to use whatever the question asks you to use. If not, then you can choose, right? So direct or set associative, you can choose which one is easier. So you have to show, right, how the calculation being done until you get the cache addressing. All right, so this one already been covered in cache chapter, so you can go and do the revision on the calculation part. All right, so for bus, you also need to declare the bus, right? So normally in bus, then you need to show that you have address bus, you have data bus, and you have control bus, right? So for address bus, you have to say what is the size of your bus. So in our case here, for example, if you are using 64 megabyte, right? So our bus address bus size is going to be 24 bits. Right, for data, it depend on the processor, right? So let's say we are designing for 32-bit data, then our data is 32-bit. Then control, you don't have to specify because this will go into the detailed design, but you can say it is in the might be in the range of 0 to 10, right? Because we cannot say what's the size, but it's gonna be more than one, right? It's not just 0 and 1. Okay, then yeah, so for bus you need to specify the bus size. Okay, so for multi-core design, so it's the same like the single core processor, but the difference is that it exists in multiple. Then you have, this one is the chapter that I covered, so you guys can show, can go and check in multi-core design, and then how the multi-core processor, so the multi-core processor is being connected, right? So you have to know how to draw the connection, right? So same goes as the single processor, right? So for example, for the single processor, so you have to draw the bus, and you have to draw where's the processor, right? So where's the memory, so what are the connection that being connected, right? So you have to show it, and then you have to determine. So you have to explain, you have to specify the number, and you have to draw, right? So for single core, and then for multi-core, then you have to even know how to draw, right? So let's say the multi-core, and then if there is a cache involved, right? So you have to show, right? So where you put the cache, right? And then what level of the cache, is it L1 cache, L2 cache, right? So where is it being located in your design, and you have to specify what are the size of the cache. And then for multi-core design, right? So you have to know what are the technique that you can use to interface the memory. Everything has been covered, right? So you have to specify, right? So you have to look for clue, right? You have to look for clue whenever it involve what kind of data. Is it huge amount of data, right? So if it's a huge amount of data, so how is being connected, right? So that's where the DMA comes in, right? Direct memory access. So this is the module that you need to have. It involve huge amount of data, but and then you still need to know how it's being connected. Right. So I think not so much. So that's all the thing that you need to know. So the rest, I'm giving you the skeleton, right, of what we're going to cover in the design question. So based on the points that I've given, right, so you guys have to go into this chapter and see how the calculation and connections being done, right, so that when during the open book exam, you guys won't have any problem, right? Thank you so much. That's all from me.